So here's the deal. Degrees are not the only unit of measurement that we can use to measure an angle. It's the most common in applications, but in just pure mathematics, when you're just crunching numbers and higher level math, they use radians as opposed to degrees. It's like the difference between inches and feet. Okay, it's measuring the same stuff, it's just using different units to do so. So let me tell you what the definition of a radian is, or one definition of a radian. A radian is found by dividing the arc length S by the radius R. So a radian is found by dividing the arc length S by the radius R. So our radian angle theta is equal to S divided by R. Here's something else we need to know. There are 2 pi radians in an entire circle. Okay, there are 2 pi radians in an entire circle. So if we want to convert degrees to radians, can we use something that I just told you to do that conversion? Okay, the 2 pi, but do we just multiply by 2 pi? Divided by 360, okay? Why would we do that? Think about converting feet to inches, or excuse me, let's do inches to feet, okay? If we convert inches to feet, what do? Divide by 12, because 1 foot has 12 inches. So, if there are 2 pi radians in an entire circle, that's 2 pi in 360 degrees. They're equivalent to each other, they're just different units. Now, does that reduce? Yes, to pi over 180. So this is actually what we're going to multiply by, just so that we have one less thing to type into the calculator. You could multiply by 2 pi over 360 degrees, but you're having to type in an extra button in there that you really don't have to. So to convert degrees to radians, we're going to multiply our degree angle by pi over 180 degrees. But we're not going to just completely multiply it out in the calculator. The majority of the time, radian angles are left in terms of pi. Okay, we leave them in terms of pi. So that means when I type this in, I'm not going to type in the pi. I'm just going to do 115 divided by 180. It's very rarely going to be a whole number, so I'm just going to go ahead and hit fraction. And I've got a pi left there in the numerator. Okay, so 115 degrees is equivalent to 23 pi over 36. Now, we don't have any units. Okay, you do not have to write the word radian beside it. It's just assumed when you're talking about angles, if there's not a degree symbol, then that answer is radians. So from this point forward, I'm going to get real picky. When you have an angle, if it's degrees and you don't put your degree symbol, I'm going to start counting off a little bit. Okay, you got to put the degree symbol, because if there is no degree symbol, it's assumed it's radians. Okay, 115 degrees is very different from 115 radians. 115 degrees is very different from 115 radians. So you got to put that degree symbol if it's degrees. Okay, so if we do 85 degrees multiplied by pi over 180, okay, 85 over 80, reduce that, 85 over 180, reduce that to 17 pi over 36. Okay, 350 degrees, 350 over 180, whoops. Okay, 35 pi over 18. Notice 35 pi over 18 is very close to 2 pi. 36 over 18 would be 2 pi. Well, 350 degrees is very close to 360 degrees, right? It's close to the entire circle. So 360 degrees in a whole circle, 2 pi radians in a whole circle. All right, so this is going to come in handy here in a minute, but let's just practice, make sure that we get it in our head to convert to degrees, or excuse me, to convert to radians, we multiply by pi over 180. So do 17 through 32 there on your work.